Imagine receiving a signal from the most distant human-made object ever built. A spacecraft so far from Earth that its radio messages take nearly an entire day to reach us. A machine launched in 1977, still traveling through the darkness of interstellar space nearly half a century later. That spacecraft is Voyager 1, and despite its age, it continues to surprise scientists in ways nobody expected. Over the years, countless headlines have claimed that NASA confirmed Voyager 1 discovered something impossible. But what did Voyager 1 actually find? Was it evidence of alien technology? A mysterious object drifting through deep space? Or something even stranger that challenged our understanding of the universe? The truth is, every new signal Voyager 1 sends back has the potential to rewrite what we know about the edge of our solar system. When Voyager 1 launched, its mission was supposed to last only a few years. Its primary goal was to explore Jupiter and Saturn before continuing into deep space. No one expected the spacecraft to survive for decades. Yet, somehow, it kept going, farther than any spacecraft in history. Today, Voyager 1 is more than 24 billion kilometers from Earth, traveling through a region of space that no human-made object had ever explored before. It has crossed the boundary known as the heliopause, the point where the sun's influence begins to give way to interstellar space. In other words, Voyager 1 is no longer exploring our solar system. It's exploring the space between the stars. And that's where the real mystery begins. Scientists expected conditions beyond the heliopause to change dramatically. The magnetic field, the density of particles, the environment itself, everything was expected to behave differently. Instead, Voyager detected something that puzzled researchers. The magnetic field on both sides of the heliopause was surprisingly similar. According to many earlier models, scientists expected a much larger change in direction. Instead, the transition appeared far smoother than anticipated. It wasn't impossible, but it was unexpected. And it forced researchers to rethink how our solar system interacts with the vast ocean of interstellar space. That wasn't the only surprise. Voyager also detected that the space between stars isn't empty at all. It's filled with thin clouds of plasma, magnetic fields, and energetic particles moving through the galaxy. By listening to tiny vibrations in this plasma, scientists have even been able to estimate the density of interstellar space around the spacecraft. It's an extraordinary achievement. Imagine measuring the properties of an invisible ocean without ever leaving the tiny vessel floating inside it. And perhaps the most incredible part is this. Voyager is still teaching us new things. Even after nearly 50 years, its aging instruments continue sending precious data across billions of kilometers, helping scientists understand a region that no human has ever visited. Every signal is a message from the frontier of the unknown. Every transmission reminds us that exploration doesn't end when a mission reaches its destination. Sometimes, that's where the greatest discoveries truly begin. But as Voyager travels farther into the darkness, one question becomes impossible to ignore. What else is waiting out there? Could future spacecraft discover environments unlike anything we've imagined? Could the boundary between our solar system and interstellar space hold more surprises? Or is Voyager 1 already witnessing phenomena that future generations of scientists will spend decades trying to explain? One thing is certain. The farther humanity looks into the cosmos, the more the universe reminds us that it is far stranger than our theories alone can predict. And Voyager 1, our oldest explorer, is still leading the way into the unknown. But Voyager 1's journey didn't stop after crossing into interstellar space. In many ways, that's where its most fascinating mission truly began. Every day, the spacecraft moves farther away from the sun at more than 17 kilometers per second. It is traveling so fast that, in a single year, it covers a distance of more than 500 million kilometers. And yet, on the scale of the Milky Way, that speed is almost meaningless. Even after nearly 50 years of non-stop travel, Voyager 1 has only moved a tiny fraction of the distance to the nearest star. If it were heading directly toward Proxima Centauri, our closest stellar neighbor, the journey would still take more than 70,000 years.
Think about that.
Entire civilizations could rise and fall before Voyager reached another star. And still, it would continue drifting through the darkness. One of the strangest discoveries came when scientists noticed something completely unexpected in the data. Even after leaving the protective bubble created by the sun, Voyager continued detecting particles that appeared to originate from our own solar system. How was that possible? Researchers had expected the heliopause to act like a clear boundary, a line separating the solar wind from interstellar space. Instead, it behaved more like a coastline, a turbulent region where particles from both environments could interact in surprising ways. The edge of our solar system wasn't a wall. It was a frontier, a place far more complex than anyone had imagined. Then something even more unusual happened. Voyager began detecting powerful shock waves traveling through interstellar space. These weren't explosions happening near the spacecraft. They were caused by enormous solar eruptions that had left the sun years earlier. Imagine that. A burst of energy released from our star could travel billions of kilometers, eventually reaching Voyager long after the event itself had been forgotten on Earth. Those shock waves compressed the surrounding plasma, creating faint oscillations that Voyager's instruments were able to detect. For the first time in history, scientists were effectively hearing the environment between the stars. It was like listening to the heartbeat of interstellar space. Every signal helped researchers map a region no spacecraft had ever explored before. And the surprises kept coming. Measurements suggested that interstellar space was more active than expected. The density of particles changed over time. Magnetic fields shifted. Cosmic rays behaved in ways that challenged existing models. None of these discoveries meant that physics was broken, but they did reveal something just as exciting. The universe was more complicated than our best theories predicted. That's the true purpose of exploration. Not to confirm what we already believe, but to uncover what we don't yet understand. And perhaps that's why Voyager 1 remains one of the greatest scientific missions ever launched. It isn't taking breathtaking photographs anymore. Its cameras were turned off decades ago to save power. Instead, it has become something even more valuable, a silent scientific laboratory, floating alone through a region where no human-made object has ever traveled. Every tiny packet of data that reaches Earth has crossed more than 24 billion kilometers of empty space, traveling at the speed of light for almost an entire day before arriving at NASA's antennas. It's astonishing that we can still communicate with a machine so unimaginably far away. Even more astonishing, that it still has something to teach us. And perhaps the most emotional part of Voyager's story has nothing to do with science. It has to do with time. One by one, its instruments are being switched off to conserve the little power that remains. Eventually, the spacecraft will fall silent forever. No more signals. No more discoveries. No more messages from the edge of the solar system. But even after that final transmission, Voyager's journey will continue. Alone, drifting endlessly through the Milky Way. Long after Earth has changed beyond recognition, long after every person alive today is gone, Voyager 1 will still be traveling among the stars. A tiny ambassador of humanity, carrying a story that began on a small blue planet and continues in the endless darkness of space. And maybe that's what makes Voyager 1 so extraordinary. It isn't the fastest spacecraft ever built. It isn't the most powerful. It doesn't carry the newest technology. In fact, by today's standards, its onboard computer is incredibly simple. Many modern smartphones have millions of times more computing power than Voyager 1. And yet, no machine in history has traveled farther. No mission has explored a more distant frontier. No spacecraft has shown us more clearly just how enormous the universe truly is. Every signal Voyager sends back reminds us of something remarkable. Human curiosity has no finish line. When Voyager launched in 1977, no one knew if it would even survive its encounters with Jupiter and Saturn. Instead, it exceeded every expectation. It became the first spacecraft to leave the solar system, the first to directly sample interstellar space, the first to show us that the boundaries surrounding our sun is far more complex than anyone imagined. And perhaps it won't be the last. Future spacecraft may travel even farther. They may reach nearby stars. They may discover planets capable of supporting life. They may uncover phenomena that completely rewrite the laws of astrophysics. But every one of those future missions will owe something to Voyager, because Voyager proved that humanity could reach the unknown. It proved that exploration doesn't end at the edge of a map. It begins there. One day, Voyager's power will finally run out. Its instruments will go silent. The last radio signal will cross billions of kilometers before arriving on Earth. And for the first time in nearly half a century, there will be nothing more to hear. But that won't be the end of Voyager's story. It will continue orbiting the center of the Milky Way for millions of years, passing through clouds of interstellar gas, drifting between distant stars. Perhaps one day, long after humanity is gone, another civilization may find it. If they do, they'll discover the famous golden record, a small gold-plated disc attached to the spacecraft. Inside it are sounds from Earth, music from different cultures, greetings spoken in dozens of languages, the laughter of children, the sound of rain, ocean waves crashing onto a beach, the heartbeat of a human being. It's more than a collection of recordings. It's a time capsule, a message that says, "We were here." Imagine finding that record millions of years from now. It would be the only surviving evidence of a civilization that once lived around an ordinary star in a quiet corner of the Milky Way. Whether anyone ever hears those sounds, we may never know. But perhaps that was never the point. Voyager wasn't built because we knew what we would find. It was built because humanity has always been driven to explore, to ask questions, to cross horizons, to venture into places where no one has ever gone before. That's why Voyager 1 is more than just a spacecraft. It is a symbol of curiosity, a reminder that even the smallest machine, built by a tiny civilization on a small blue planet, can leave a mark on a universe almost too vast to comprehend. So the next time you look up at the night sky, remember this. Somewhere out there, far beyond the planets, far beyond the edge of our solar system, Voyager 1 is still traveling, still carrying humanity's message into the unknown, still proving that our greatest discoveries begin the moment we dare to leave the familiar behind. If you enjoyed this video, don't forget to leave a like, subscribe to the channel, and turn on notifications so you never miss our next journey into the greatest mysteries of space and the universe. Because every discovery, no matter how impossible it first seems, brings us one step closer to understanding our place in the cosmos. And who knows? The next signal from the darkness could change everything.